Hello everyone, and welcome to this solution stream for Säkerhets-SM. One moment, I'm just gonna turn off the monitor for the microphone. This is very annoying to hear myself with a slight delay. Okay, right. Nice. So, yes, some introduction. The Swedish High-School Championship in IT security just ended. It was competition took place this weekend, started Friday evening and ended now just 10 minutes ago, where high school students in Sweden tried their hands on some various problem in IT security, an introduction to CTF. And the idea with this stream is that I'm going to go through and try to solve the challenges and explain how to approach them and what tools to use and other considerations. I will try to monitor the chat as well. So if you have any follow-up questions or if you have additional input, feel free to write in the chat. And yeah, let's before we dig into the actual challenges, we can take a look at the scoreboard. So we see that we had about 58 teams competing. Some of them were not high school students, so they were not competing for the prizes, but still wanted to try the challenges that we made. So I think there were about like 45 high school teams of at most 3 people. So in first and second place, we have the Swedish CTF team, whatever. They split up into 2 halves and raced against each other. So big congratulations to them. They managed to solve all the challenges. In third place, Dagi CTF also managed to solve all of the problems. So these are the top three finishers of the competitions. But I mean, a big congratulations to all the teams that participated, and I hope you had some great fun. So yeah, let's dig into the challenge. So I will be approaching this. I mean, my kind of target audience for this stream are beginners, and so I will try to go through and talk about how to approach these different challenges and what to think about and how to solve them. I will not do all of them today, but my idea is to split this up over maybe 2 or maybe 3 sessions, but we'll see how far we get today, and then I'll plan around that. By the way, if there's any technical issues, like if the sound is not good, or if you can't see the text or whatever, please write in the chat so that I can try to fix that as soon as possible. So these challenges are divided into a few different categories. And we have the regular CTF categories. It's like reverse engineering, pwnables, which is like exploitation, cryptography, forensics, web. There's this special category, boot to root. It's a chain of challenges. We have some miscellaneous challenges that didn't really fit anywhere else. And they also had the introduction category, which is specifically designed to teach some concepts to new players. So let's see. I think it's suitable that we start with the introductory category. And I will be, let's see if I can let's already we're going to start with the encoding 101 challenge. So I'm just going to update that so the status bar says the correct name. Yes, great. So here we have the challenge, encoding 101, solved by 45 teams. So most teams solve this. So basically, this challenge is about data and data encoding. And here is a slight introductory tutorial. And what we're saying here is that we're talking about encoding and how to convert a string such as hello world into hexadecimal. So one thing that's like done implicitly here, what's like taken for granted, which is not spelled out directly, but I think it's important to point out. I mean, hexadecimal encoding is, hexadecimal is a base to represent numbers, and hello world is not a number. So first we turn these characters into numbers, and then we turn those numbers into a different base. And the most common encoding for characters used to be ASCII encoding, and it kind of still is. And then there is the of this, which is Unicode. So I'm not going to talk about Unicode today because that's a little bit more complicated, but at least for ASCII, it's fairly simple. We have basically this table. Every character, every string character is assigned a number, and they are given 1 byte each. So we have room for 256 different characters. Now, this used to be a 7-bit thing. So the ASCII standard is up to 120. So 127 different characters. So we can see here, for example, like the letter A is given number 97, and so on. So when we talk about hexadecimal representation of text, we're actually talking about hexadecimal representation of the ASCII representation of that string. So that's something to point out. And yeah, here is another link to a Wikipedia article. So here we are given a string of hexadecimal digits, and we want to turn this into a flag. So just gonna create a directory. And I mean, there are a lot of different ways you can do this, but I like to use Python for a lot of things. And in Python 3, there is the bytes class, which has a from hex function. So basically, if we run this, we will take this sequence of hexadecimal digits, and we will turn this into a sequence of bytes. And this sequence of bytes also happens to be a sequence of characters. And this is another encoding. Let's see, did they... No, they didn't say anything about this. So this is another way of encoding data. So hexadecimal is just base 16. For every byte, we take 2 digits, and they are the digits 0 to 9 and A to F. And it's just a regular different base, like base 10, base 2, whatever. This is yet another base, but here this is base 64 data. And how would you know that? So the giveaway is that let's look at base 64. So base 64 is just another, it's another number base, but we need 64 different characters to represent our digits. And for base 64, the standard way of doing it is to use all the letters of the alphabet, both lower and uppercase, all the digits, and 2 additional characters, for example, plus and slash. But in some contexts, for example, URLs where those have other meanings, these are usually replaced by something else. But the point is that we have 64 different characters, which is very often or almost always the letters of the alphabet plus the digits and 2 additional characters. Additionally, if you base 64 encode your data, what you do is you represent 3 bytes of data with 4 base64 characters. And that means that your base64 data needs to be a multiple of 4 characters. And if it's not, we pad this out with these equal signs to indicate that this doesn't actually contain any data. So if you have data with these like trailing equal signs, 1 or 2 of them, that's also a clear indicator that this is base64 data. So Python also has a base64 module, and we can use the base64 decode function and just take this string, copy it, run it, and here we have a flag. So we copy this, submit it, and we'll solve the challenge. And what I usually do when solving challenges is that I always make some kind of note, either like a solution script to solve it, a text file with some notes what I did. This way you can go back and see what you did. I mean, okay, in this case it's kind of simple, but it's good to build this the habit of doing this. So let's move on. We have remote 101 solved by 46 teams, and most teams solve this. Basically, this teaches you how to, I mean, most people nowadays are usually used to like communicate with the world through a web browser using the HTTP protocol. But it's important to note that there are a lot of other protocols. Do just like a raw TCP connection to communicate with the remote service. And one tool in most Unix-based systems is Netcat, which basically just makes a TCP connection to an IP address and a port and connects that with the standard out and standard in of your terminal. So what you can do is you can take this, we can run netcat nc. There are different flavors of this tool, but for this simple use, it doesn't really matter which one you use. So you specify the IP address and then the port. You run this, and in this case we connect it and it gives us a flag. So, oh, I forgot to update statusing. Anyway, we connect to this, this remote service, and we get this flag. So let's just write this down and also actually submit the flag. So the point with this is that when you start doing other kinds of challenges, which are not web challenges, for example, there might be occasions where you need to communicate with some remote service using just a raw TCP connection, and this is one way to do that. We will get. I will explain later how we can actually do this when we're like scripting things and automating things. But yeah, that's it. One. Let me just. I got a question how I get my terminal syntax highlighting. So yes, my environment here, just to quickly explain, I'm using a shell called C shell or ZSH. And with this, I'm using like a plugin framework thing called OhmySosh or OhmyShush or something. And specifically, I'm using a plugin called syntax highlighting or something. You can find it on GitHub, which provides this. You see, when I try to write a command which does not exist, it turns red, and then when I spell it correctly, it turns green. So that's very convenient. And yeah, I'm running this in a. I do all my CTF stuff in Linux in a virtual machine. Well, sometimes I use other operating systems as well, but I always start from my Linux VM. Specifically, I use Ubuntu, I think. And yeah, and you will see some others. I will go through the tools I'm using as we go. Anyway, the ELF 101. So, I mean, I guess a lot of people are most familiar with Windows and coming from a Windows world where you have your exe files, which are your runnable files, your programs. In Linux, the standard format for like a run executable program is called ELF, and so you need a Linux system to be able to run them. And as I said, I'm using a VM, a virtual machine, to run Linux. But there is also in Windows, you have this Windows subsystem for Linux, which is a way of basically running Linux inside of Windows. I have not used it myself at all, actually, but I know a lot of people who use it, and some of my developer friends, they actually use it for their everyday work and development and stuff. So yeah, it works fine. So the question is, any reason for using a VM? Well, I mean, I'm running Windows as my main OS because I play games and stuff. And also keeping it inside a VM is good to contain if there would be anything malicious or anything that would like mess up your system. You can easily just, reset everything. And also my laptop is a Mac where I also run a VM with the same kind of setup. So I'm able to have like a very similar setup, even though I'm on two different computers. So yeah, I just find it convenient. I'm using VMware Workstation or VMware Fusion for the virtualization, but you can as easily use VirtualBox for this, which is free to use for non-commercial purposes. So yeah, you can use that, and there are tons of guides on the internet on how to set up a VM. Anyway, we have downloaded this file, which is called ELF, and we can try to verify if this is actually an ELF file by using the file command. So file ELF tells us that this at least seems to be a 64-bit ELF binary. So we can try to execute this. It says permission denied. So why is that? That is because these files, they have permissions on them. They can be designated as readable, writable, and or executable for the owner, the group, and other people. And you can see that this file has not been marked as executable. So we need to do that. So we use this command, chmod +x. So we add the executable flag to this file. And now if we look again, we can see that it is executable. So we can execute this file, and here we have the flag. So we take all of that, put it in a notes file, we copy the flag, and we solve the challenge. Okay, great. So we managed to make it through the intro challenges. So let's go through the actual challenges. Someone suggested that we start with the miscellaneous challenges. So yeah, let's go with that. There are a few of them and not too difficult. So this category is things that don't fit in the usual categories that you usually find in a CTF challenge. And what are the usual categories you find? Well, if you play CTF challenges, you will know, but typically it is this reverse engineering, pwnables, cryptography, forensics, web, and sometimes there is like we call PPC, so like algorithms and programming challenges. And there are other there could be like hardware or electronics challenges. So sometimes they put those in like reverse engineering or pwnable, or sometimes they make it their own categories. So some people make up extra categories, but these are some of the standard categories. And miscellaneous is other stuff that doesn't really fit. So here we have, it's called Discord. Let me just update the status. Okay. So basically, this is a very common thing in CTF competition. So usually there is some kind of chat, like an IRC channel or a Discord server or something, to be able to communicate with the organizers and other participants. And the organizers want to encourage people to join this. And therefore, typically you create a challenge which serves two purposes. One purpose is to show people what the flags look like, and the other purpose is to get people to join whatever communication channel they are using. So here it says that you can join the Discord server, and also says the hint that you have to look a little bit. Oh, that's not good. Now I can't really show you this on screen since I'm not running Discord inside the VM. Yeah, it's somewhere on the Discord server. Basically, join the Discord server, find the flag, put it here. So it's that's the purpose of these kinds of challenges, just like to get people into whatever communication channel they are using. So let's just leave it as an exercise for the listener. Someone is. Oh, sorry, it was in the topic of the. So if you join the Discord server, let's see if I could just do this with like an anonymous account. Can I do like this, or do I have to actually create an account? No, okay, cool. I can use the web thing. No, I don't want to claim an account. So here's the Discord server. So this Discord server is for the organization that hosts this competition. It's a Swedish organization called CodeSport. So we do like competitive programming, some related things to that, and then like some CTF stuff. And in the security, in the channel for this competition, in the topic, there is this flag. So yeah, let's submit that. And yeah, we'll close down this Discord and move on to the hidden in plain sight. So I'm just gonna update the status. Okay. So this year, this is the for the poster. So before this competition, we tried to spread the word a little bit by creating a poster for this, and on that poster there was like a warm-up challenge. So let's look at this image. Yeah, so it's an image of different types of like two-dimensional barcodes. And depending on how much you work with these before, you might recognize some of them and maybe know what they're called and how to decode them and so on. But my guess here is just like that the flag is just split up in 4 parts maybe and divided between these. So this first one, I think most of you should recognize as a regular QR code. And let's see if we can. So I know that my phone, regular, fairly recent iPhone, can decode this very easily. So I'm using an app called QR Reader, and we can just scan this QR code and that will work. But what you can also do is that there is a tool called CBAR-IMG, which can decode QR codes for you. Now, I don't know if I need to like chop this up for this to work. No, it will work. So this CBAR-IMG is a tool to decode a QR code. So it says here that the first part is like SSM don't for. Let's create a like notes thing here. So, okay, that's good. That's the first part of the challenge. And let's look at the rest. I mean, I recognize these others, the second one and the third one I think I've seen as well. The fourth one I'm not sure if I recognize, but what we can do is that, first of all, let's close down a few Wikipedia articles. So let's search for like a list of 2D barcodes. And there's like a list. So someone made something here. You have the QR code. This seems like we recognize this. This one kind of looks like the third one here. So it could be a PDF 417. Let's come back at that. And then this one seems very similar here as well. This is called an ASTIC code, apparently. However, the color one is not here. Let's continue to look at this. Oh, the Wikipedia article is pretty good. Let's look at these images. Yeah, this JAB code looks very similar to what we have here. So the guess here is that we have a QR code, an ASTIC code, a PDF 417 code, and a JAB code. So let's try to decode these one at a time. So ASTIC code decoder. And maybe we could just chop these up. I don't know if this can be seen on. I'm just quickly using my like screen capture tool to just chop these up into their different components so that we don't confuse the decoder. So you can use whatever image editing program you want, and just, you know, crop this up into the different parts. And just copy this into my VM. So let's see here. This website claims to be able to decode ASTIC and PDF code. So let's look at the ASTIC code, upload it. Yeah, okay, it gives us something. Let's put that in our notes. Great. And the PDF code also gives us something. So right now we have a flag which says, don't forget to register for the, maybe it's gonna say competition or something. Now, does this decode JAB codes? No, it doesn't seem to. So let's search for JAB code decoder. So this is scan code. So let's see if we can upload this. Oh yes, and it does decode it. So we take these 4 components, put them together to make a flag. You submit the flag, it's correct, and then we get to do the very satisfying thing of closing down a gazillion tabs that you opened throughout solving your challenge. All right, next miscellaneous called beautiful files. So let's update the status. And so, have you ever seen such beautiful files? SSH to this IP address and this port and read the flag. Use the user CTF and the password hunter2. This is a reference to a classic excerpt from an IRC log. You can Google that. Okay, so SSH, secure shell. It's a way to connect to a remote server and run commands on it. Let's close this down. So we use the SSH command with the port, with the IP address, and then the port, which we specify by doing -p and the port, and then the user, which we put here. So CTF at, so this is like user at IP address. So we can connect. It asks us to verify the fingerprint of the server. We'll just assume that I'm not being man in the middle. And then password hunter2. So now we have connected. And there is some like message of the day stuff. And then there is some error messages from, I think someone put very strict configurations on this. So let's try to run ls and see that we have a bunch of files with very strange file names. And the flag is apparently in one of these. So one thing you could do is you could try to like print out one of these flags, but unfortunately it's messy with these special characters. You could probably try to do, no, because we're running just this very simple shell, so there's no tab completion, of course. What we can do is just search all of these files, of course. We could use grep with the -r to find this prefix of the flag. So what we're doing here, grep is a tool to search for strings in some data. You can either specify to search it in a single file or like in a whole directory. So this is like -r for recursive. And then we search for this string SSM and we search in this directory. And apparently we're not able to run that at all. What we can try then is maybe some wildcard stuff. So we could do cat and the or just cat star. This will try to read all the flags. Print out. It will. The star will expand to all different file names. So we'll try to print all the different file names. So it claims that there is no flag at all in these files. Let's see, did we actually print all of the files? So these are, I'm thinking that we missed one of the files. So this was 17 outputs from 17 files. So do we have other? Why is there like another hidden file somewhere here? So we're getting some suggestions from the chat. Cat star -a. Yes. Okay, so I can explain what's going on here. These file contains special characters, which is like a caret return. So when you're printing one of these files, it will print all of these characters and then jump back to the beginning of the line and then continue writing characters, effectively overwriting the previous output and overwriting the flag. So the flag is actually never outputted. So that was why I was trying to run XXD, because if you're on your own system, if you're in a normal functioning system, and you have some file which has some kind of strange content, and you really want to see what's in the file, you can use XXD, which is a it does a hex dump of a file. So let's, as an example, just copy some of what we did here. Copy this into our notes.txt, and then we can do XXD notes. So what you do here is that it will convert the file into hexadecimal, all the bytes, and then the decoding next to it. So here it would not like respect this special characters, and it would print out all of the data, and you would see the flag. Now we didn't have this on the remote server, so we couldn't do that. Someone was suggesting, so there are other suggestions would be to run strings. I think strings is not available on this system. Another one would be to actually, this is an interesting one, which is a hybrid, where you run SSH and you run the command cat star on the server. So first let's do this, hunter2. So we're not connecting to the server and like getting a shell. We're just connecting to the server, running one command and getting the output. But if we then pipe that output to the XXD of our local machine, that would also work, because here you can see the hex dump of this file. So I would say that's probably one of the nicest solutions. You don't have to know specific flags of the like file thing expansion. So let's put this in here. And what you could, I guess you could also do then, instead of XXD, you could do like strings. Yeah, that would also be a very clean output. Strings is, by the way, a tool that reads data from some, either from a file or from standard input, and just prints out all the printable strings that it can find. So if you had some kind of blob with mixed non-printable and printable stuff, you can run strings to extract all the different strings. Anyway, that's a little bit about like file names and some commands. Did I submit this? No, I did not submit this. Okay, cool. We are done with the miscellaneous category. And as I said, if you have any questions throughout, if you want some clarification on anything, please write in the chat. So let's move on. I think we should look at the web challenges, because I think web is like the area which people tend to have the most experience with when they haven't played CTFs before. So, and yeah, so the first web challenge is Perfecto Desk. Okay, so I've actually created this challenge, so I'm not going completely blind here, but I will try to explain how I would approach it if I didn't know this, already know the solution. There's a question here if there will be another pony racing. Yeah, I will. I can talk about that later. So Perfecto Desk solved by 9 teams. I think it was a little bit more difficult than I intended. We run the best customer support desk in the world with an absolutely perfect track record. Check it out, and then we can go to this website. Okay, so here's a website. Here is some description about their great service. It's just garbage. It doesn't have anything with anything to do, except that they are really fast at solving your problems. So it says down here, powered by PHP and SQL. That's good to know. We know some of the technologies. And there are 2 other pages. You can submit a ticket. Here you can submit your name and email address, and you can submit the ticket. And it says your ticket has been submitted. Your ticket ID is this number. Okay, good. Let's copy the number and go to the check ticket. Let's put in that number. And it says we could not find a ticket. The issue must have already been resolved, which is expected for of our excellent system, of course. Not that we think you do, but if you need further assistance, please submit a new ticket. Okay, that's a bit strange. You can't find the ticket you just submitted. So maybe you can try to play around here a little bit. Try to be really quick to submit this and then check it immediately and stuff. But that's all red herring. Actually, the code for this form, it doesn't actually input anything into the database. It just generates a random number and prints it to the screen. So yeah, there's that. However, this part, it does actually look for stuff in the database. And let's just approach this from a black box perspective. If we were to create such a function for our website, let's just bring up a document. If we were to create this function, we would create some query that we would run against the database. And the query could look something like select from maybe tickets, we don't know, where, I don't know, maybe ID is equal to, and then the ID. So the query could look something like this. I mean, we don't know if it's selecting all the fields. It might as well be like select ID and name and status or whatever. And this might be called like submitted tickets, and this might be called ticket ID. We don't know. But it's a reasonable guess that the query looks something like this. And if that's the case, and if there's the case that we have a SQL injection here, then we should be able to transform this into the quote, and then do a union select, and then a number of fields. And if what this will do is that first it will try to match rows where the ID is something. Let's say it doesn't find anything, and then it will append this union, and select one just selects a dummy row with one column with a 1 in it. However, these two selections, like this part and this part, needs to have the same number of columns, otherwise it will not work. And we don't know how many columns they are selecting or whatever, but a reasonable guess is that it's not too many columns. Like it might be like 1, 2, 3, 4, 5 columns. Maybe, it could even be as big as like 10 columns, but it's probably not like 500 columns in the table. So, let's try to do this injection. So we would do this union select 1, and then we want to terminate this query. So do like a semicolon and some comment thing. Try to do this. It doesn't work. Okay, let's add another column. Try this again. And actually, if we continue, even if we do like a bunch of these, it still doesn't work. Okay, why could that be? Could there be something else in this query that's actually not what we think it is? So actually, maybe what if this is not double quote, but maybe it uses single quotes. So we need to redo this whole thing using a single quote here, because otherwise it will turn into this, and that just means that we are looking for a ticket with this ID, which obviously won't exist. So let's redo it. Single quote, union select. You can see from my autocomplete that I've done this before, but okay, it doesn't work with one column, and we can continue. And when you get to 4 columns, you instead get this. Oh, that's interesting. So let's put this down. So apparently we're selecting 4 columns, and 3 of them are getting printed back to us. So now we can replace one of these entries. Instead of just selecting a static thing, we can insert a subquery. So we could do, I mean, what do we want to select? First of all, we could just, test that our subquery is working. Okay, that works. Okay, fine. Now we need to figure out exactly which flavor of SQL they're using. What is the backend here? What database server is it? MySQL, Postgres, whatever. So if we go to like SQL injection, like cheat sheet, and look at things that it could be. So you want to have some, you want to look for things like this, things that differentiate the different databases from each other. So let's go with this one from, MySQL is probably the most popular, so let's start with that. So just run this query. Okay, that did not work. So let's go with the one that looks more like this. Didn't work either. Let's look again. Okay, so it's not MySQL, it's not Postgres, it's not Microsoft SQL, Oracle SQL. I mean, that sounds like a bit of a stretch. I mean, who would use that kind of database? No, it's not. Okay, so what have we missed? Well, there is another popular type of SQL database that has not been mentioned, which is SQLite. And let's search for some things here on Google. So there's GitHub repository. If this is SQLite, we should be able to use this one to get the SQLite version. So let's run this query. And it works. Okay, so the database is SQLite. So now we know that. Okay, so we can close all of this down. So how do we get... I mean, we want to know what's the name of the table and what columns there are so that we can start dumping the database. So what we're looking for here is in SQLite, there's this table called the SQLite master. And that contains the data about the different tables. So we want to run this query where it says like select table name from SQLite master where type is table and table name does not start with SQLite because we don't want to select these like metadata things. So we put these things together, put this into our subquery, and we run it. Okay, so there is a table called tickets. That's good. Are there other tables? So we could do like limit 1 I think would be the correct syntax. Oh, right. So there's another. So we go through these like one at a time using the limit. So there is a table called flag. Okay. So what are the column names for this flag table? So we could in this SQLite master, I think there is like a column called like SQL. Yes, so this is the definition of this table. So there is one column called SQL, which is like the query that would create this table. So let's change this. So we just specifically say that we want stuff from the table called flag, and we want the SQL for that. Whoa. So let's run this query. Oh, we should remove the limit. Okay, cool. So we get this. It says create table flag, and it has two fields called ID and flag. So probably the flag is in the field flag in the table flag. So select flag from flag and then try to run that. And we get the flag. So that's how you can solve this challenge. There is another way, which is fully automated. There's a tool called SQL Map, which is a tool for automatically doing SQL injections. And it will find the SQL injection and will just dump everything for you, but not with the default settings. So let's try this to just see that it works. No, actually, let's not. But the thing is that when you run this, you need to turn up the risk factor to higher than the default to make it do some more thorough tests to actually find this. But when you've done that, let's see. Yeah, you can then use SQL Map with a command like this. You turn up the risk factor, and then you can start dumping things, and then you can dump tables and stuff. It's a really convenient tool. You should check it out if you haven't used it before. So that's the Perfecto Desk challenge. Let's move on to the colors and the shapes. Okay, sorry. Yes. So here is another challenge I created. So, but I will try to pretend that I do not know the solution really. So, made a super pretty website about my favorite interests. Okay. The colors and the shapes. Hello visitors, I love colors and shapes. In fact, I love them so much I've created this gallery full of colors and shapes. To not make it confusing, I've divided them up into 2 pages, the colors and the shapes. Convenient. Please use the menu above to go look at the colors and the shapes. Okay, so the colors, image gallery, some colors, the shapes, some shapes. Okay, checks out. So what can we do? Look at the source code here and see that these images are not actually the image files referenced directly. Instead, this is actually referencing a PHP file, and then it's providing the name of the file as an argument. Okay, that's interesting. Let's open that in another page. So here we have this URL. Let's create a document. Note that we found this. So what happens if we can change this to the other thing, we get other files. Okay, so this PHP script is probably going to this path, probably prefixed by something, and then opening that file and just printing it out to us. So what if we change this to etc/password? Okay, we get some kind of error. So let's so the problem here is that since this is an image, it's supposed to be an image, the web server is probably sending headers saying that it's an image, but actually it might not be an image. So we look here at the network tab and we reload, and we see that yes, it says that it's a content type is image /png, but in the preview, I mean, it doesn't work. It's trying to parse something that's not an image. So we can use curl instead. So we just make an HTTP request to this URL, and we get text back. So we're actually reading this file from the file system, this /etc password, which is the file that contains the list of all the users in the system. And it's a good when you're doing these things where you try to read a file from a server, it's good to try with a file like that, because you know that this file will exist. So it's just removes one source of errors. But okay, let's continue with this. So if we can read that file, maybe we can read some file in this web server. So for example, there is this shapes.php. So let's try to read that one. And where is that one? So let's say this is running in this gallery directory. What happens if we run just shapes.php? Okay, here it says it failed opening this file, and we see that it uses the PHP function require once. That's interesting fact, because that also means that if the file we're including would include PHP code, it would actually run the PHP code. That's something to keep in mind. So let's go one step up in the directory. Still doesn't work. And let's go one step up. Okay, so that works. So that means that it's running in this gallery directory, and we need to go 2 steps up to get to the root to get shapes. That means that it's not prefixing the path with anything. So the code probably just looks like something like this. Just take the p parameter and just read that file. Okay, so that's interesting. And also note that even though we are including a PHP file, shapes.php, there is actually no PHP code at all here. So the PHP, if there was any PHP code in the shapes.php file, it's executed and we just get the output. So here comes a neat little trick in PHP. The PHP filter function. So, and this is just, this is a crazy feature, one of the many crazy features in PHP. When you open files in PHP, you can have different like protocols. You can do like just file : // which is like read a file in the local subsystem. You can use like HTTP or HTTPS or FTP even to read a file from, as if you read the contents of a URL as if it was a file. So you could do like, you could write code where you would say like this. Then you would go to that site, grab the contents of that, and then include it as part of your script. But there's a special protocol handler it's called PHP : //. And it allows you to set up like a pipeline for the stuff you're reading and run different functions on it. So basically, you can use this filter thing. And what it does is that it says that we want to run this filter subsystem thing, and we want to specifically apply the convert.base64 encode function, and we want to apply it to the resource, for example, index.php. So this will insert like a pre-processing stage. So before the actual contents are read into the PHP interpreter, it will go through this pre-processing stage, and that the result of that will be read by the PHP interpreter. So in this case, it will like read the contents, base64 encode it, and then pass it on to the PHP interpreter. This means that if there's any PHP code, it will no longer be executed because it will no longer be PHP code. It will be base64 encoded PHP code. So let's start with just doing this with the image, because it should be in the same folder. So we take the original request and we replace the file name with this, and we try to request that from the server, and we get a lot of base64 data. Now, if we base64 this, if you base64 decode this, this is just that image. Okay, so let's try to do this then with this shapes.php. So we go up 2 steps, shapes.php. I should spell properly. Okay, we get some base64 data. Now we could save this to a file and then like run base64 decoder this, or we can just pipe it directly to the base64 decoder. And here we get the actual PHP code that this shapes.php is. Now there isn't anything interesting in this file specifically, so let's look at the other files. We have the colors, and then we have the index, and there is actually, so this is like an index file, which means that invisibly this is like index.php. So let's look at that one, because that's like the main file. So, and here we have a flag. Amazing. So let's submit this. So the things there, what we did here was we used a local file inclusion vulnerability. That's what this thing is called, where you manage to like read or get the server or whatever to like somehow read or interpret a file that's already on the server, but it was not supposed to. Either just leaking it or executing it or some variant of that. So it's called a local file inclusion, LFI, and we use this PHP filter function to actually get the code and not the result of executing the code. Because I can contrast this to, let's see if we just would have requested the index file without this thing. We see we only get like the output and the flag is not here. So yes, it's a good reference in the chat as well, and yes, moving on to the next one. Flagdmin. Okay, so let's close down a few tabs and close down the notes. Flagdmin. Okay, so built with modern Node.js, Redis, TypeScript, and all the good technologies. This is the service for all admins to get their flags. So we get the URL, and we also get some TypeScript source code. So let's go to the URL. It says error, cannot get /. Okay, so let's look at the source code. And here we have code, a lot of code. So where do we start? Let's try to find the actual endpoints. We have the different endpoints here. So this is a Node.js app. So it's written in, well, in this case, it's TypeScript, which is a programming language that is like compiled into JavaScript, and it uses the Express web framework. So what we do here is that we define a few different paths that we can request. So we can do, for example, this one, API/redirect, which will redirect us to this website, Digital Ungdom. And so let's look at this. We also want to get the flag. See here, there's a reference to a flag. So this endpoint, it looks like it's just doing a bunch of like garbage stuff, like if one random number is equal to another random number and the time is equal, the random time is equal to something. And it's like, basically this is never going to be true. So we're never going to get the flag from here. This might as well say if false for all intents and purposes. And let's see, this one just says I'm a teapot. This one will just echo back whatever we send it. So this login thing, this seems to do something. Okay, let's get back to this. So this is basically the way I would approach things. I do like a quick pass over this to try to see like where should I even care to look. So the login still relevant. Get flag, it says that if our user ID, so like client, okay, so we use our user ID to get a username, I guess, and if that's admin, we are allowed to do a lookup on the flag ID to get the flag and send that back to us. Okay, interesting. So then there's some other stuff. Okay, so how can we be admin? Does it create like an admin user anywhere? When we log in, So this client, what is this actually? Okay, it's a Redis. So it's a Redis. It's a key value database. As like a dictionary or a map data structure, but in a database. So it will map like a key to a value. In this case, it seems to be mapping like an ID to a username. So, or actually maybe like an ID to like a user level, because it is like user and admin. So here we can basically, we can log in. We can use any user ID we want, and it will be set to user. Okay, so the goal here is try to kind of like bypass this to make us become admin instead. And then when we do that, it will look up in this DB, which is a MongoDB. And here you can clearly see that they do yeah, I'm wondering if this is probably like so like in the same way you can do like SQL injections in like structured databases, like classic like table based like MySQL and so on. You can also do injections in like NoSQL databases. I'm not as familiar with that, but I'm suspecting that we could just use this flag ID to get this to extract much more than that is supposed to. However, to even get to this, we need to first sort this part. So the question is, could we do like a Redis injection thing here? Let's look at all the places where we even use this interact with Redis. So we create the Redis client there, and then it does some kind of setup, which I don't really know what it does. No, it doesn't really seem to. It never sets anyone to admin, so no one is at admin. So let's do some Googling. Let's see what this is called. Where is the Redis stuff? The Redis server. So Google for like Redis server set injection maybe. Let's look at these results. So I'm wondering if is this thing just concatenating things together into a query? We can maybe even look at the is this the library? Redis server. Yeah, I think this is this looks like the library we're using. So if we look here at the set function, where is so this is the code for this library, and someone says I'm looking at the wrong library. Okay. Um, let's see if we can search for. Oh shit, yeah. So, okay, sorry, I was looking at the Redis server library. This is the library that we want to look at. So, could this be the one? Yes, this looks more like it. Here you have like the Redis, the client, the set. So that looks good. And here is the question is then, does this do any kind of escaping, or is it just concatenating together these things and creating a Redis command? So where is this set function? So this is a lot of specifications and stuff, but this is a lot of code. So can we get the documentation for the set command? Okay, so they're suggesting commands.js. Yeah, I think it's good that some people are. So here, add command. Oh, so is it just dynamically? So what are you saying is? Oh, right here. So it will run for all the commands. It will run the add command function. Where are these defined? Wait, what does it use a? Is it using like an external thing to just dynamically define all the commands? That's interesting. You're also saying that the exploit is in the README. Are there any like warnings or? What are the examples of? Oh, wait. Can you just... How is this called now again? So... So assuming that this is actually parsed as an object, like a JSON input, we could provide just an array as the first. That's stupid, but okay. Let's try this. So let's try to just interact with this. This now we want to actually interact with the server. You can do this in a lot of different ways. You can use your browser, you can use an attack proxy. I usually just do some Python scripting because that's where I'm most comfortable. So I use a Python library called requests, which is a very nice library for doing HTTP requests and interacting with web servers. So we can do request, and let's see, was this a post API? Yeah, so we do a post request, and we do this to API/login, and we want to create like a JSON post body, and a whoa. Okay, so we want to have body. So let's start off simple by just doing just normal like nothing fishy, and just do this and just print the response to just see what happens. So this is our JSON body. We submit it here to this URL, get the reply back, print the response. Nothing fancy. Oh, we're not actually supposed to get any body in the response, so just print the status code as well. Okay, 201. So that seems to work. So let's try this now with replacing this. Instead of putting a string here, let's put an array here. So we want to have the key and the value in this array. So our user ID is an array, and the key is my user ID, and the value is admin. And that seems to work. Does this actually, let's do something. Can we like do something that should not work and just see if we get like an error? Okay, whatever. Let's just hope it worked. So let's hope we are admin now. I don't know if there's any way to check it. Can we see? Oh, right, because when we try to do this API call to get the flag, if we're not admin, we will get the 401 back. Otherwise, we will get whatever result we have from this API, the database lookup. So let's make another request. And now we need to have the user ID, and this time this should be my user ID, and we also need the flag ID, and we don't know the flag ID, and we probably won't know the flag ID because we're probably going to do some injection stuff. So let's just put a 0 there. So let's try this. Nice. Let's just compare this to yes. So what we see here is that we are in fact admins, because we are getting the 218 response back, which means that we are inside here. Okay, so now we come to the MongoDB part, and I assume that we can just do some kind of NoSQL injection here. the question is, I need to look up the documentation for this. First of all, let's close all the Redis stuff. And then do MongoDB find one. Because I think that, if I remember correctly, this function, you can either input like a specific ID, or you can create like a what do you call it, like a constraint, so like a query. So in the find one thing, we should be able to do something like so this would be the like non-malicious way of just, we could just put an ID here, but I think we should be able to, like, yes, this is what we're looking at. So we want to insert an object there, which is taken as the like constraint, like the where clause. So we just need to put some clause that's always true. So we should be able to do something like this. So here we're just saying like the flag ID should be greater than or equal to 0. Now, if it's actually an ID and it's numeric, this should be true. So let's try it. No. Can we do this then? Maybe it's an empty string. Yes. Okay. So first we tried to do this with, we try to create a query where we say that the ID should be greater than a number, but the ID is not a number, so the comparison returns false either way. So then we just create an empty string instead. So when this is sent to the server here, and it runs this gets combined together like this. So we're running a query against the database where we say, please find me one document where the ID is greater than empty string. And that is true for the document that's in the database because it has this ID. And here's the flag. All right. I'm actually going to, because I want to keep up a little bit of flow in the stream, so I will actually, I think I will skip this more difficult challenge for now and move on to another category. So I think, yeah, that's a good way of doing this, because I don't want to get too stuck on any of the more difficult challenges at the moment. So I think for this first session, I will focus on these the simple challenges, and then for the next session we can look at the more difficult challenges. So let's do reverse engineering, because that's my favorite category. So just gonna switch this, and we are now moving over to the first reverse engineering challenges. This is another one of the challenges I made. It's called Snek. So you're walking down a forest path when suddenly a huge fearsome snake with venomous fangs attacks you, and we get this file. Okay. It's a gzip to tar archive, so we can extract it with tar xf, so tar extract file, and then the file. And we have a file called Snek, and we don't know what kind of file it is, so we run file, and it says that it's Python 3.6 byte compiled. So what is this? This is the intermediate format that the standard Python interpreter uses for the Python code. So when you write Python code, you write it in a human-readable text format, and the regular Python interpreter, before it actually executes it in the Python virtual machine, it will translate the Python code into this bytecode, this like intermediate step, and then run this. And this is such code. And if we use the xxd command again, you can see that this is not human readable. These files usually have the .pyc file extension, though this one does currently not have that. Okay, so we can see there are a few strings here, and then there's a lot of unreadable stuff. There's something here that like almost looks like a flag, but it says oof instead of SSM. A lot of people, this is pretty funny, you can go to the statistics page for here you can look at all the wrong submissions, and there are a whole bunch of submissions of this non-flag. That was not a flag. We can run the strings command on this. We get a few things. We get this. We get some string here, maybe some original file name, some other strings, some Python libraries. And we could try to run this, I think, but it's probably not going to work because I think I have a different Python version. So we can rename this to Snek.pyc and then try to run this. And yes, so these are specific to the different Python versions, and I am not running 3.6, so this will not work. However, doesn't matter. We want to decompile this into human readable thing, and there's a program called uncompile6. It's a Python package itself. You can install this, and then you can run uncompile6 on this code, and it turns it back into somewhat readable Python code. Okay, so this is the Python code that's running. We have some sequence of bytes here. We have this thing. It takes some input. It will append a null byte to make sure that here it basically, this will make sure that the input is of even length. Then it will take this number, and then it will go through. So it will go through 2 characters at a time, 2 bytes at a time, and it will append the result to this list, and the result it will append is the CRC32 of those 2 bytes using the previous CRC result as the seed value. Okay, so that's what this is doing, and then it will drop the first element, the seed value. So it will have things that are just based on the input. Then we'll take all these numbers and treat them as 32-bit integers and pack them into a sequence of bytes. Then it will XOR that sequence of bytes with this oof string repeated, and then it will compare this against this target value. Okay, and if it's correct, it will say this. So how do we solve this? Basically, I mean, we could of course just undo this XOR thing. I mean, we could work our way backwards here. We want to know what the input should be. This is like solving this equation. So if we XOR again with this oof string, we will get back what these CRC checksums must be. And since it's only performed on 2 bytes at a time, we can brute force all of those values. So let's write some code to do that. We will copy some of this. And this utilizes the fact that you can, if you have like x or y equals z, you can, like, XORing with itself undoes the operation. So like if you XOR both of these sides with y, this part cancels out. So we can use this to undo this thing. So if we XOR these two things together, we could print this out. Okay, this is a sequence of bytes, but it doesn't really mean anything to us. So next we need to undo this step. So first of all, let's call this like the target CRC bytes instead of just B. And then we can use the struct.unpack, and this is a number of integers. So since we know that this was produced from a sequence of 32-bit integers, each of them will be packed into 4 bytes. This thing should be a multiple of 4 bytes. So let's just make sure that's the case. And then what we can do is that we can divide the length of this by 4 to know how many integers we expect. So now we have the target CRC vals. So let's print this. Okay, I mean, we have no idea if this is correct or not, but it seems plausible at least. So let's add this seed value back in to make the iteration simpler. And we turn this into a list from a tuple. Oh. Okay. So now we need to do the brute forcing. So what we want to do now is to start with, we need to start to figure out what are the two first bytes of the input supposed to be. So we need to consider all the different combinations of 2 characters. Now we can assume, since this program takes the inputs, like it seems to take like a text input or something, so we can assume that this is like printable ASCII characters. So what we can do now is we can use the this itertools function product, and in the string library we have so this function called the itertools product, it will take the a Cartesian product of a number of inputs repeated a number of times and just give you an iterator for all of them. So I can just show you the output of this. you know, you see it here, it will do like every combination of two printable ASCII characters. That's great. And then we want to calculate this CRC sum for this. So we want to, this is given as a pair, like a tuple. So we just we join them up, and then we also encode that into bytes, and then we calculate the CRC of this using, so we have like an index variable here, and we will take the target CRC vals and the index, sorry, the seed value will be the current index, and then we will say that if this CRC is equal to the next value in the list, then we found the proper one. Then let's keep track of our results. So in that case, we append those characters to the result, and we break the iteration because we found this. So let's just do this for the first iteration and see if we find something. Okay, it runs very fast, and it says that the first two characters are SS. That seems very reasonable because we expect the flag to start with SSM. So let's, instead of having like a static index here, let's replace this now with a an iterator. And since we increased the length of the this list by 1, we just subtract 1 here. So now we should be able to run this. We could actually just print the partial steps as well, and there we get it. Now I think, so we're missing the bracket at the end, and I think that this is because we know that the code here was adding a null byte to the end, and we're not using that. So let's just, you know, for completeness, add in so that we do the product over all the printable characters and the null byte. And now it manages to find the last pair as well. So that's how you solve that one. So this challenge was solved by 15 teams. Yes. And as I said, if you have any questions or, you know, want me to talk about some details on any of the challenges, please write so in the chat. Otherwise, let's move on to the next challenge called Diffcomp. So download the compiled program and some good tools for reverse engineering: GDB, Ghidra, Binary Ninja, Hexrace, IDA, Radari 2. Some solid advice there. So let's look at this. Diffcomp file. It's an ELF binary. We know how to run these. Enter password. Incorrect. Okay. So yeah, someone said that the cutter should be on this list. Yeah, so cutter is a GUI to Radari. Radar is more of a command line or like read line style interface. I'm going to use the Binary Ninja Cloud. So Binary Ninja is a tool for reverse engineering, and they have this like web version of it, and it's free to use, and we can use it to disassemble this. Sorry, we can use this to disassemble a program. So let's just upload this program and disassemble it. So this is Binary Ninja. So what we see here is, will this break if I try to... no, we can actually increase the font size. Great. So here we have all the functions it has identified, and here you see the start function and the disassembly of the start function. And we can go through to the main function here. And you can see here that it okay, so reading disassembly, reading assembly code. This is, something you have to learn and something that comes with experience. And it's like reading any other code, except that it's typically very, very verbose, and it requires practice to learn this. But what you can try to do is try to look for some like key elements, like the major like the structure of the program, some major parts of it. So for example, here you see as a reference to this enter password string and a call to the print f function. So around here it probably prints this string, and then without reading every single instruction here. And then it calls this scanf function, and then it calls this passcomp function. So it will then either print correct or incorrect. So probably what happens is that the actual kind of stuff that happens goes on in this passcomp function. And in this passcomp function, we have, let's see if I can zoom out a little bit. Yes. So here you have some static values, and then we have some kind of loop here in the middle, and some way of breaking out of the loop. I see the loop we can break out of the loop from here. There are 3 places. It's here, here, and here. And by convention, the return value of this function is in the EAX register. So you see that the return value can be here either 0 from these branches or 1 from this branch. And so we're trying to figure out what does this function do. And basically we would need to find, first of all, we want to know where the argument comes in, and this differs depending on what type of binary it is. So this is a 64-bit ELF binary. So if you look at Linux calling convention, x86 calling convention, and then we go down in this table, we can see that in x86 64-bit for Linux, the parameters to a function, and you have the argument in the RDI. The first argument to the function is in the RDI register. The second one is in the RSI register. So here we look at the. Here we see that the argument comes in, goes into this location. So we can call this the password. And here we see that the password is used for the first time, where it's sent to the strlen function, and the return value of that in the AEX register is then compared against 0. And if it's equal to 0, it goes down here. So it just checks that there is a password. And what happens then? It will check that it will take the password and then dereference that pointer and compare this to this value. So basically it's checking that the first character of the password is an S. So that's very, very reasonable. That's what we are expecting. And otherwise it will go down here and break. It will go down to this. So we assume that 0 is a bad return state. We want it to return 1 is what we're assuming here. And what we're doing then is to store 1 in this variable. And let's see what that's used for. So you can see here that it starts by assigning 1 to this variable, doing some comparison here related to whether we should continue the loop or not, and then adding 1 here. So this kind of feels like it's the like iteration index. So let's rename it to that. So what's happening more then? We are taking this index and we are comparing it against this value. 30. So if we get the index to be 30, we will break out and set this return value to 1. So I guess the password is supposed to be 30 characters long. So what are we doing in each iteration of this array? So we read the index variable into the EDX register. We read the password pointer into the RAX. We add them together. So basically we're getting the memory location of the current character. And then we dereference that here, move it into the EAX register, and then move it into, so the AL is referencing the same. So the AL is the first byte of the EAX register. So this is the 32-bit version, and this is the 8-bit version of the same area. So here we're getting the character and then moving it into the EDX register. So now the current character is in the EDX register. There was some question here about why I'm not reading the decompiled code. I assume you mean from, for example, like Ghidra, which has a decompiler. I will contrast this by starting out doing the disassembly here, because it's important to get a feel for disassembly, and then we will use a decompiler for another of the challenges to just get a contrast there. Because I mean, decompiler is good, but you need to know this as well. So I'm using this fairly simple program as an example of and sometimes the decompilation won't really work at all. So where was I? Here we have the current character, and then we take the index here, subtract 1, move it into the C register, get the password, add those together, and dereference that. Okay, so this is, so EDX will be, can we add like a comment here? No, maybe not. So someone said, like, seems like assembly is very overkill compared to the rest of the required knowledge. I mean, in a sense, it is a bit, can be a bit daunting to approach, but also it's really not that complicated once you get a hang of it. And I mean, it's just code, right? It's just that since everything is like so small instructions, everything becomes very verbose. But the thing is, like, when you have looked at this for a while, you're not reading the individual instructions anymore. You start to see patterns. It's I usually compare it to when you learn to read. Like when you first start out reading, you look at the individual letters. There's like D, A, D, and that's dad, and then you put that together. But now when you know to read, that's not how you read. You like read, you see like the shape, the general shape of a word, and you just know that that's the word. Like you recognize the bigger block. Sometimes you can even read like, you know, half a sentence. You just recognize the shape of a phrase, and that's how you read. You don't read the individual letters. And it's exactly the same with assembly. So anyway, so basically here we have that the what it does here, it takes, so we get down to here where in this EDX register we have the current character, and then here in the EAX register we have the previous character, and then here it will subtract the previous character from the current character. So that's now, so the EDX is now the difference between the last character and the current character. And then we again will read the index, and then we will look at this, which is, oh, right here. So this is basically an array. You can see that this is like consecutive memory addresses. F, E, D, C, B, A, 9, 8, 7. It's minus. So these are like a consecutive block of memory. So it will start at this address, and then add this index here and do a comparison. So it seems that basically what it's doing, it's like taking the difference between the last character and the current character and comparing it against this sequence of bytes. And it's also checking that the first one is an S. So let's just then create a script that will generate the flag based on this knowledge. So just extracting all of these bytes. So we call this the diffs, and then the result is an array of characters, and we know that the S character should be there from the beginning. And then basically we can just do this, like for every diff in this list of differences, let's just calculate the next character by taking the value of the last character, and then so the difference we have is the current character minus the last character. So we solve this equation and just move that over. We can take the last character and add the difference. So we do this, but this have to be we have to wrap around. So it's like 1 byte, it's modulo 1 byte. So we mask out. We take only the last the eight least significant bits of data, and then we append this to our list. And then when we're done, we join all of those elements together and print it out. And then you get here. Apparently there's actually a mistake here because there are 3 S's here. So yeah, there's a comment here about like assemblers seem like a big hurdle to get into CTFs. I mean, that's kind of true because it's not something that it's not really something you learn anymore. Like even if you do like computer science at a university, you will have like 1 course or something covering assembly. But yeah, it's really important if you want to work with like lower level stuff. So let's compare this to the decompiled code. I will use IDA, which is not free. You can also use Ghidra. You will get similar output. I mean, the decompiler in Ghidra it's good. It's not as good as Hexrace for the things that Hexrace can handle, but Ghidra can handle more different architectures. So it depends on what you're doing. So opening this up in IDA, we can decompile this, and we get something that looks like C. We can look at this decompiled code, and we know that these are actually not like a bunch of different variables. They are one array. So let's fix that up. And it's actually so these are the diffs. Here we have something called the stack cookie, which I won't go over right now. Here is the input password. Here is the password length, and this is the index. This is, let's see. Yeah, so here you can see the decompiled code, which just it loops over the array, and it checks that the current password, current character minus the previous characters. Oh well, if it's not equal to the difference, it will abort and return 0, and otherwise it will continue through the whole loop and return 1. So that's what it looks like if you decompile the code. So this is why it's very good that Ghidra has been released and is free, because it makes these things much more accessible. But I cannot stress enough that it is important to eventually kind of start learning assembler as well. I mean, in this particular case, using Ghidra and the decompiler would be enough. But the decompilers are not perfect, and there will sometimes be mistakes or things you can't decompile or something. So yeah. And the questions, if there are any good resources to learn assembly on your own, I would say I mean, this is kind of difficult, right? Because it's a lot like both a science and a craft. There isn't really like, you know, a set step of things that's like, you know, you can work through these things and then you will know everything, because a lot of it is like developing this like sense of like pattern recognition and experience and stuff. So ideally I would just, you know, I mean, the way I learned was just do reverse engineering challenges in CTFs. So I would start out with, there are some like really good beginner CTFs that have their challenges, they keep their challenges up. One of them is Pico CTF, where you can look at the previous year's exercises. I mean, they have all the different categories, but you mean you can focus specifically on the reverse engineering ones. I mean, for some other categories, there are some really good websites, but for reverse engineering specifically, yeah, maybe there's someone should build this. Anyway, by the way, did I submit this flag? I did not, right? Cool. Okay, let's close this down. Move on to double protection. And we get double the passwords, double the protection. Yeah, well, about that. So we get this file. We can, it's also a compiled ELF64-bit binary. So let's use Ghidra for this one to really like do the full showcase of so we run Ghidra. What project? Okay, whatever. No, let's close this. I will show it from the beginning. So close project, and then I will show you what it looks like when you start this up for it. Okay, so here, this is what Ghidra looks like. You create a new project. Cool thing is you can do like a collaborative thing with like a server and work on things together. I haven't tried that, but that might be cool. So we open the Code Explorer tool and we import the file called double protection, and it tries to automatically identify what kind of file this is. So it's an ELF64-bit, so we'll just go with OK. It will do some initial analysis. We want to do the analysis. Yes, just default settings, analyze. Okay. I'm gonna see if I can. Let's see if I can increase the font size. Is it like, yeah. So this is Ghidra. There's a question how much IDA costs. Depends a little bit on what modules you want and so on, but it's ballpark a couple of €1,000, I think. It's like 5,000 euros or something like that. yeah. So it's, I mean, it's not really a hobbyist tool. Anyway, so this is Ghidra. You get the disassembly here, you get the decompilation here. Let's look at the main function. Did it identify it? No, it has a bunch of functions here. So this looks like it's doing something. Can we... where is the stuff? So here is the entry. Yes, okay. So this is the entry point of the program, I think. And it will call... where is... Yeah, it will call this function. So this is the entry point of the program. Let's... So double protection, let's run it. They ask for password 1, password 2. Nothing happens. But it looks correct. Like here we print password 1 and 2, and then it calls this function and this function. So let's see, this variable here we can rename to password 1, and this one is password 2. So we go into this function. So these are password 1, password 2. And what it does is, so there's a bug in this challenge. This thing here, it should say password 2 here. There's a bug in the code, but it's still solvable. It's just that if you run it, even if you run it with the correct input, it won't work. So there's a bug. But yeah. So let's see, what is this thing doing? It's checking that. So this is our index. This is another index. So getting quite readable output. So the question, so first one says that Cutter has the Ghidra decompiler as a default plugin. Oh, nice. So they actually implemented the, so I'm using Ghidra here with the Ghidra interface, which I'm not a big fan of, but I mean, the decompiler is pretty good. So yeah, but Cutter, which is originally a GUI for Radare, apparently now has implemented the compilation using the Ghidra backend. So that's actually really interesting. So you should definitely check that out. If you just search for like Radare Cutter or visit cutter.re. And I mean, this is a project that's worth keeping a look at, because they're making some good improvements to this. But I'm still gonna use Ghidra for this challenge this time anyway. Someone asked if I bought IDA or gotten it through work or something. Yeah, so at my previous job, I had it through work, and then I bought it myself using some prize money from CTFs. Yeah. So what is this thing doing? It will, if this should be how do I edit how it views this? Okay, anyway, oh, so this will it will modify the password by doing, let's see, if the password, maybe this is like uppercasing it or lowercasing it or just encrypting it or something. It will modify the password using this formula. So not super important at the moment. Let's go back to the so let's call this like modify passwords. Oh, and also, by the way, it will then concatenate the passwords at the end. And then it will go into this function where it will so this is our password, and then it will do the same operation on these two things. So these are not actually numbers, these are strings. You can see that these are like in the printable ASCII range. So we could just see that I think this is one string, and then this is one string. So we could just copy this into a so this is an interesting thing of reverse engineering, is that, I mean, data is data. It doesn't have any like inherent true interpretation or whatever. So like it's just bits, right? But you have to choose how to interpret this memory. And in this case, Ghidra has chosen to say that what's going on here is that we have a 64-bit integer to which we are assigning this 64-bit number. But an equally valid interpretation is that we have like a slot of 8 bytes where we are storing 8 characters. It's just shuffling data around, so it's the same thing. So data, so Ghidra here has chosen one interpretation of this, which I do not agree to. But unfortunately, I'm too much of a noob in Ghidra to actually tell it to reinterpret this. So let's just do this in Python. So we use this struct library again. And basically we have a 64-bit integer followed by a 32-bit integer followed by a single byte, and then we have the same again. So we can just use this function to pack all of this together into a sequence of bytes. Right click, change type. Okay, let's do that. Or is it here? Maybe I have to do it in the, wait. From the assembly listing, all right. Oh, retype variable. Okay, that's what it is. So we want to do, can I do just char and will it understand that it's an, no, we'll have to do char s8. Can I do this? Or just this? Okay, so it is changing the type, but it's still not viewing it as as a string. So yeah, if someone knows how to do that, then please tell me. In the meanwhile, I'll just do this because this is good to know as well. So we can do this. So we get some kind of garbage characters, which is because this password modification thing has been performed on it. So we need to undo that as well. Yeah. And so what we need to do now is to undo this password modification thing. And what it did was like it added, so here it says add minus 54. So subtract hex 54. So we need to add back that. So we will do for every byte, we will add 54 and then make sure that we wrap around and just take the last byte. And we do the same thing here. We run this and I made a mistake. So oh wait, this should not be, again, this is showing this as a new line character. So now we have to actually think about this. They're doing two different things here, of course. So it's saying that if so it's like a Caesar rotation thing. So basically it's saying that if the character plus 10 is still under 7F, then it will add 10. A new line character is 10 in ASCII. And otherwise it will do subtract 54. And this is basically, this is the highest printable character. So if we just we subtract, so they add 10, so we need to subtract 10. Okay, so let's do this properly then. So what is minus 54 is also AC. Yeah. So this means that we need to account for these two cases. So if the original character this like hashed character is in this range of like 7F minus 10, then we should subtract 10, and otherwise we should do this add 54. So we need to account for these two cases. So we subtract if this x is larger than 7F minus 10 and still less than 7F. Otherwise, we will do the plus 54 thing. This should be the algorithm, right? Now I'm getting confused. Wait, so let's subtract 54, but we... No, because that's what they are doing. Wait, it doesn't have to be... Oh, I'm stupid. Okay. Yeah, so for most characters, so if the character is, this is same thing as saying like if, what's 7f minus, so if the character is less than, so what they did was like, if the character is less than the 7.5, then they will add 10 to it. Otherwise, they will subtract 0x54, 84 to it. So we need to undo this. So let's assume that this so in most cases we will just be subtracting. Does that make any sense at all? First, what's happening when we... And also, is the SSM thing included in this, or was it printed? No, okay, so we should not expect it to start with SSM. Okay, so you can see that some of the characters come out correctly, but some of them are not. And the reason for this is basically that would mean that anything below 10 or above, okay, so that would be, so either if it's in this range of I mean, obviously the lowest possible, so you can think of it this way. The lowest possible value that still goes into this branch is 0. And the resulting character will be 10. So if the character in the hash is 10 or more, then we can subtract 10 because we knew it was in this branch. However, if the highest possible character that can go in here is if it's below 7.5. And in that case, it will become 7f. And if it's not, we should add this, do it the other way. Or so I thought. What are the bytes here anyway? maybe we can assume that it's starting out with printable characters. So only if it's the lowest, like apart from like new lines and stuff, the lowest printable character is space, which is this one, and if we add 10 to that, it will become this. Yes. Now we get something. So let's do this for both of them. It's looking better, but I'm doing some kind of mistake. Am I making this the wrong way around? Oh. Okay, so chat says I'm doing it the wrong way around. Yeah, probably misread something. So in that case, just if it's, and this would be the, okay, that worked. Let's just go back and see where I misread. So what the code does is it takes our password and it performs this like transformation. And then it will take this thing and perform the same. But wait, then why didn't, let me just go back in that case, because why didn't this this is the wrong way around. If it takes our input, and let's call this like a hash or whatever, and performs this hash on our input, and then it takes this data and does the same hash and then compare them to each other, then this should be the, then this should be the input. Is this completely broken? Okay, I mean it does work, so yeah, but it feels like it's backwards. I just want to try, like, does this even work with the binary? So this was the first half. Yeah, okay, sorry, I'm just... No. Yeah, so I'm hearing what you're saying, but I think this is wrong. It takes my input, which should be the flag, or maybe not, whatever. It's the password. It takes the password. Let's call this the hash or whatever. So this is the concatenation of the modified passwords, okay, that we pass to this like check passwords function. And then it will take this like target password 1 and target password 2. Oh, now I see. Okay, yeah. Okay, I see what you mean. This is I'm sorry, I had it backwards. So it will take these garbage characters and make sure that they, when they modified, become the flag, and if so, it will print the flag. Okay, that makes sense. This also means, by the way, so we should do this. This means that the flag will be in memory. Like this will contain, sorry, this S2 will contain the flag in memory. So we could also just do this dynamically with the debugger. So let's start with GDB, and we set the breakpoint at this location after it has modified this function. So can I copy this address? Set the breakpoint here. Run the program. And what the can I oh sorry yeah, so we need to set the proper breakpoint. So we start the program and then we set the breakpoint here. Then continue. We just insert 2 passwords. Or maybe this is just the offset that we want. So yeah, okay. So let me just explain what I did. So if we run this with a debugger, we can start the program and then take this offset here in the code. Sorry, this is where it calls the modify password. So let's take the offset. Well, actually, let's do that. That's good. Take this offset. We can set a breakpoint there and then let the program run. And we just put in any 2 passwords. So here it breaks at the where it's about to call this function. So we then can type next instruction, which means that we will not step into this function call. It will run until the next instruction. So run this, and now the return value from that function contains the flag. So that's another way of doing it. Okay, sorry for that detour. That's how you can use a program such as Ghidra. Don't want to save this. And and GDB. And I'm using, for reference, this is GDB with the Pwn debug extension add-on. So this is like an add-on to GDB, which adds a lot of nice extra features. Okay, anyway. Moving on. Let's look at overly attached OS. Okay. So, solve this. Okay, so let's use the I'm gonna try to see what this looks like in Binary Ninja, but then I might go over to IDA. So we download this disk.bin. And we can look here at the instructions and see that we can run this using QEMU. So QEMU is an emulator that you can use to emulate a whole bunch of different systems. So let's just put this into like script to run this. Okay. So basically, if we look at this file, disk.bin, it says it's a DOS/MBR boot sector. So this is not this is not just like a program. It's like a boot sector. Like this is the thing that would run like when your computer first start. The thing that would load your like bootloader or like a grub or something. The very first part of code, apart from the BIOS or something that would run. So this is not like a program. It's more like a chunk of code that would run. So, okay. So let's open this up in Binary Ninja. Now I'm using the desktop version. Okay, so let's see if we can. So what we need to do is that we need to tell this that this is actually code. x86. But the thing is that we also need to tell it that it's supposed to be at a different address. Because when this code is loaded, you see now it says that this is address this is address 0, but this is actually not where it's loaded. So if we look at this like MBR entry address or something like that, we can get, yeah, so this is the address that it will start at, like 7C00. So can I get Binary Ninja to rebase this? Let's see if they've done. So, okay, we need to do this. Open with options. Yes, okay. Base. So can we add in the, we need to put in the base address here somewhere. I wonder how we do this. Analysis. I just want to change them. Otherwise, I will just switch to IDA where I know I can do this. But you should be able to. What if I just go okay? No. Let me try this again. Okay, screw it. You're supposed to be able to do that, but I don't know how. I've never done this in Binary Ninja, so I will use IDA for this one. So we open this, and we want to disassemble this in 16-bit mode, and this also loads at address 0, which we don't like. So we want to move this segment to this address. And now we go back here and we see that it starts at this address 7C00. So we can say that this is code. And so what it does is that it sets up some, I mean, I barely know what this is, and then it will set the stack pointer to 7000, and then we'll jump to this location, and here it will read, let's see, read sectors into memory. So it will start reading data, and then let's see. I mean, I still don't know exactly what I'm looking for, but we have some stuff. Here are some strings. We could look at those. Here's also, there's a whole bunch of data here. A lot of, wow, a lot of strings here, and a lot of other data, and also a lot of strings. So yeah, okay. So we don't really know exactly yet what this is, but here there's at least some code. So let's try to run this because we haven't done that yet. So, okay, it runs, and it says, it prints out a bunch of garbage, and then it says, give me your flag so that I have something to remember you by. So let's just type something, and it says like, oh my god, this flag, are you even trying? I can't handle this, panicking, and so on. Okay. And then it doesn't seem to respond anymore. So that's what it's doing. So in this thing, let's define a function here and look at the code. So this is like the code of what it's doing. So it's, I think I saw something. So what is happening here? It's, it's doing some like comparisons here, and they are, I mean, here it's doing like XOR BX BX, so the B register will be 0, and then it will do some comparisons. I mean, these could never be true, so I'm not sure what's going on there. Anyway, I saw something here. It's calling, this function is being called in a bunch of places. So let's look at this function, what it's doing. In a loop, it's writing characters. So this interrupt here is writing characters. So specifically, is it just how many times is this doing this? So, well, let's call this just print for now and go back. And then it needs to print something, right? So, for example, here, it's loading this reference to this like press key to retry print. So maybe this argument is in this SI register. So that's, yes, cool. It's printing this invalid magic here, and oh, so we can look at these things and see these are actually references to strings. So that's interesting. So let's see which one it is actually printing when we run it. So I don't see these. So this is annoying because it looks like it should be writing these strings starting with FMBR, but they're not showing up at all. So yeah. Someone says FBTS is the next boot stage. Yeah, so where did those FMBR, does it like clear the screen? Could we like pipe the output? Yeah, okay. No. So serial. So someone says, okay, if you hook it up to GDB, yeah. So what we can do is when we run QEMU, we can add, I think it is like -G, right? Or is it -S? Let me check my, yeah, it should be G. Option not supported for this. Whoa. Why can't I debug this then? Is there another flag for? S and big S, okay. Okay, so what we're doing now is that we're starting QEMU and also starting like a GDB server on it. That means that we can go into GDB and then connect to this. So this is a way you can use GDB to debug something that's not running on like your machine, like running on something else. So so what you do then is in GDB you write like target, remote, localhost, and then the port. And now I will also need to set the architecture correctly. This is going to be an issue, I think. So yeah, I think my pwn debug thing messes up completely with the 16-bit thing. So I should just disable that for a moment. Try to start this again. And GDB art 16-bit mode. So we set the architecture. This should be the 16-bit mode, because when the computer starts, it will actually run in 16-bit mode, and it will like upgrade itself to like 32-bit and 64-bit, or if it jumps directly to from 16 to 64, I don't remember. And then we try this target, remote, localhost 1234. Yeah, this is not good. Yeah, why does this always cause so much pain? Does this try to run this again? Target, remote, localhost. So this should work, but it doesn't. Yeah, so let's just continue looking at it in IDA again. It does something here. I guess it will read stuff. Okay, so it's copying data from somewhere. Okay, so there is like a little bit of a cheat being suggested in the chat, which we will get to in a moment. So basically what this thing is doing is like it's trying to like copy parts of memory and stuff into the correct places. So here it's doing this copying, and in here it's referring to the memory. The ES and BX registers are the addresses that we should start writing to. So it will write the contents to the 7E0 address, and it will read from DL. So yeah, so I'm actually, to keep this simple, I'm actually going to do the suggestion. So basically, I guess this is like a small operating system, like booting up and then launching a program. So you could reverse this whole thing, but there's also kind of like a workaround here. So there's a tool called binwalk. Whoa. And what binwalk does is takes a big file and tries to find other files inside the file. So if we run binwalk on this disk bin, we see that inside here there's like an ELF binary, which is really cool. So we can tell binwalk to extract this. Binwalk extract ELF file. So this is what we want to do. Oh, sorry, not this. The 64-bit. Okay, this is the command we're looking for. So basically you have to give, yes, okay, finally. So basically what we're doing here is that we say run binwalk for anything you recognize. Just copy that into its own file. So now we have this folder, and this file 63F0, which is the offset. It has now extracted an ELF binary. So let's rename this to like part 2, and let's run this. It crashes. Why? I don't know, but let's look at it. Let's open it. Let's reverse it. So this part 2 thing, loading it up. So it will call some function here. Oh, did we maybe not? No, it did extract stuff. Oh, and here we have the strings that we recognize. Let's see if there are any references to here. Yes. So here is the function that's analyzing the flag. So let's assume this is the flag that we send it then. So this is and here inside his, I guess here it's checking that it starts with SSM. This looks like a mem compare thing. Let's check this out. Yes, basically this is just a doing so. You take 2 pointers and the length, and then it will check that these are equal. So we can rename this thing to memCompare. So now it's the first thing it will do is it will check that the flag starts with SSM. And this is like a print function, I guess, or it's like kernel panic thing that it was printing. Okay, so now here it's taking the flag plus 4 as an offset. So then it's doing something here. So it's doing some comparison here, and then it has this big switch case. Oh, this is annoying. Ugh. Okay. So first of all, just to make sure that we are like somewhat on the right track, let's just run this again and give it a flag that starts with SSM. And you can see that now it says like instance of bad flag exception thrown. No, just kidding, but your flag is wrong. So we got past this stage, and yeah, so here is this printout. So this is like bad flag, and this label here then is the bad flag. So we don't want to jump here. So here it's checking that so this is some memory that may or may not be initialized, and it adds a lowercase a, so it's like an index into the alphabet, and if that's not correct, then we call the bad flag function, and then we move on to the next character, and here it will it's a big switch case in a loop. So this would be a few different parts of the flag, I guess. So we start, it's like this is the current character of the flag, and it would switch on a bunch of characters. Yeah. So we call this whole function check flag. Just gonna see where it's called from. So just go up the call stack, checking where these things are referenced. So in this flag checking function, how can we get this to end in a good way? So there's a couple of different cases here, and basically we want to go through these cases in the correct order somehow. And what are these functions doing? Oh. Okay. So let's just look at these. What are these different labels? Label 11 will take this. So this is some kind of, I don't know, like counter or something. It was like a state thing, maybe. So this calls this function with this pointer. What is this pointing to? It's pointing to this, which isn't really pointing to anything at the moment. It's just a number. So let's see what this does. Okay, so this let's try to get rid of this return value because it doesn't seem to be supposed to have a return value. Okay, so this is incrementing. Okay, let's see. We have so this pointer, it's some kind of state, it's some kind of structure because it has, I think it's two different or three different pointers. Could that be the case? So yes, okay. So these three variables. Okay, yeah, big brain time. So this this is a structure containing three pointers, containing two of them are initialized to 0, and one of them is a pointer to the flag. So let's create this structure and like call it like check state, and these are integers. So let's do create this structure and then rename this to this check state. Yes, so now we have this as one structure with three fields. So this is the flag pointer. So we can say that this is a pointer to to characters, and these are like in pointers to integers. So let's just call this like counter 1 and counter 2. We don't know what they are yet. So now we're getting somewhere. So this thing takes a pointer to this check state thing, and so what it's doing is that if okay, so this is the thing that kind of like it's the state machine. So it will check if the let's see how we. So is this like a regex parser or something? So we'll basically see if the value of counter 1 is equal to this target thing. It will increment this next so yeah, I think it's like a state machine. So yeah, I think it's like a regex thing. So it's doing some kind of state machine thing where it's like checking if one thing is correct, and in that case it's like advancing the pointer. So yeah, I think this is like a compiled regex. Pretty much. So that means that these should be the transitions. And by the way, the points value on this challenge is off for a beginner CTF. Just a little note. So these start at 0. That means that we want the first one. Should be, let's see, it checks if the counter one value. So this one will be zero. Will be zero to start with. So which one of these is zero? So it will be but it seems this, because we want this thing to be called with the state variable set to 0, because that's what this counter one will be. And yeah, that's okay. Is this counter one? So maybe we could just read it off. Someone's asking if I will do any other categories. No, I think I will do this one, and I will do this Zeta Cryptor PRO, which will be much quicker than this one, and then I will wrap it up for today. So that's the end of that will be what's left today. So yeah, maybe like half an hour more, I think, for today. Yeah, so this is the problem with reverse engineering. It's not a spectator sport, and it's kind of difficult to keep this like stream of consciousness going. But the oh look, so we can read. So this state will basically tell us like the counter. It's like a state counter. If you look at these different cases, you can see that if you read these in order, so you go with the lowest one first, which is, well, let's disregard this one for the moment. But you see, like if you read like 2, 3, 4, 5, then you have M, U, S, T. So let's put down some notes. We have SSM, and then possibly something, and then must. So the first character, what could it be otherwise? Which of these have separate entries? It's just a default case. So it says that the first, or maybe the 0 and 1, it should be like D2 and CC, but that's not. That feels wrong. Because it would make sense that this one would be the first state, and then this one would be the second one. But these values here don't make sense. Is this like a different character encoding? Yeah, this is annoying. So it's a question, when is the next stream? I don't know. I'm unfortunately busy to both like tomorrow evening and Tuesday evening, so I guess like Wednesday evening could be part 2 of this, I think. Let's just quickly look at the challenges we have left. Yeah, I think it would be possible to do all of them in the second session. Don't know about the know it thing though, so we'll see. Maybe we'll do one or two more sessions. Depends on if I have some flow or not. So the current hypothesis is like this whole thing handles the first like 6 characters or something, but I'm not exactly sure what about this, because to me it should be in the like a printable range. These two are too high, so maybe it's like a different character encoding or something strange, but let's just leave that for now and then look later. So here it says that the counter should be 6, otherwise it's a bad flag. Okay, and what happens then? So it then will take the next 15 characters and XOR them with the current index plus 42. And then it will check that it's equal to this. This is not... Okay, it's 15 characters. Okay, so let's undo that operation. So we can do this in Python. It's the encrypted is just these bytes, and then we will do we will XOR it by 42 plus the index. So we use this enumerate function in Python, and what this does is it creates a generator with like both an index and the value. So it's like you will get the first element together with the 0 and so on. Oh look, so this seems very reasonable. So this would make the current known part of the flag must go maybe deep. And then what happens next? It skips ahead and it checks that, oh, it takes the next character, multiplies it by 69, and then checks that this is 6,555. So if we just take that and divide by 69, then we convert that into a character. We get an underscore. So okay, next part, basically the same thing but with 420. I'm starting to see a theme here. So we just undo this. And then again, basically same thing but with 1337. So oh, look here, it doesn't take a single byte. It takes the next 4 bytes. So here we can use again the struct thing to convert this number. Yeah. So I will explain this. So what happens here? So if you look at these things, here it takes, so it has this pointer to the flag. It adds a bit to this, so we get to offset 15 of where we were, and it takes the single byte, multiplies by 69, and checks that it's this target value. Okay, that's simple enough. And then it does this again with the next index and 420. So here where it does a little bit a little bit different. Instead of taking 1 byte, it will say that this pointer, it will like reinterpret this not as a pointer to a sequence of byte, but as a pointer to like 32-bit integers. So it will basically take 4 8-bit bytes, treat them as one 32-bit integer, multiply this by 1337, and compare it against this target value. So basically what we do is we take this target value, divide it by 1337, and that gives us a 32-bit number. And then if we reinterpret that 32-bit number as 4 8-bit bytes, then we get the 4 target bytes. So now we have this, but I don't know about these 2 first bytes. Like, what about them? There's something here that's, have they been like modified or something? Yeah, so the suggestion was to look at the assembly. So there is something tricky going on here. Oh right, we didn't check this thing. So actually we have 3 characters that we don't know about. So this one looks here. I'm wondering if so if we look at this, why? Or is this? Okay, so maybe this is the... So why is this displaying the wrong thing? Is this doing like... Is it a design thing or... Because here it looks like... So this is a thing where the compilation and the disassembly, it doesn't really agree. Because if you look here, you have CC and D2. And here it's 5F and 6.5, which is like underscore and E, which makes sense. So that must give us like E underscore. So, I mean, we could just take a guess and say that it's a W. So let's try that with a... Yeah, that works. So what happened here is, let me look at this again. Also, let me check these values. I have an idea of what's going on. No, that's... I was thinking that was like a sign thing. I have absolutely no idea why this is. I mean, this is not correct at all. This is... So, yeah, and this is why you need to check the disassembly. This is correct. This is not correct. So, yeah, sorry, I don't know what that is, but it's not correct. And by looking at the disassembly, we could get the flag. Well, we had to guess one character. I assume that this value here is like loaded somehow, like at startup, that it's filled out, that it's part of some kind of like metadata structure thing that's like filled out on startup, or that something is like copied into this or whatever. So I'm not exactly sure what it is. Fortunately, we didn't really need to know this time. So yeah, that's it. Let's submit the flag. And I think we will be able to finish the last one and then wrap this up for today. Close down a lot of tabs. We will be using Binary Ninja for the last one. Yeah, so let's see how many teams did solve that one. Yeah, it was only solved by 3 teams. The 3 teams that solved all the challenges. So yeah, that was a bit tricky. I would that should probably not have been rated at 350, especially if you really had to disassemble the kernel part. Luckily, you didn't have to. Binwalk was a good tool. Binwalk is always a good tool. So let's go with Zeta Cryptor PRO. This is another challenge I've created. So I mean, I know the solution, but I'm gonna try to approach it as if I didn't. Okay. So we are given a license.dat, a readme file, an elf binary. So let's read the readme. Thank you for downloading the trial version of Zeta Cryptor PRO. This program is designed to protect your secret with the heaviest of military-grade encryption. By simply providing a key, you can quickly encrypt any message you desire. This is a fully functional demo version for you to evaluate. The demo version is limited to encrypting messages of at most 10 characters. Damn. A full license costs $1,337. It's a lot of money. It can be ordered by sending a purchase order to cryptopro@zeta2.com. Volume discounts are available for purchase of more than 40,000 licenses. Nice. Installation instruction. To run this program, you need libsodium installed. You can, on Debian systems, you can use this. Otherwise, you can use appropriate instructions for your distribution. Note that that for the program to run, you need to place your license file license.dat in your working directory. Okay, cool. Let's run the program. Please provide an hex encoded key. Key must be exactly 64 hex characters long. Got 4 exiting. Okay. Let's set up some notes. It needs a key of 64 hex characters. Let's create that. This is 64 characters. Run it again. Key, input message to encrypt. And then we're given an encrypted message. Okay, cool. Provide a key. Let's provide a long message to encrypt. Sorry, your license only allows you to encrypt message that are at most 10 characters long, but you provide a message of 32 characters exiting. Okay, that's unfortunate. And then we were given this as well, like an IP and a port. So let's use netcat to connect this. And says, hello, have you heard about this new awesome message encryption tool? It's called Zeta Cryptor PRO and is supposed to provide the heaviest of military grade encryption. I have downloaded demo version, but I don't want to pay for license to unlock the full version. Maybe you could help me crack the program and bypass the license check. Please tell me what bytes to modify in the binary by sending an hex-encoded list of elements formatted like this. 2 bytes offset 1 byte value. For example, if you would like me to overwrite the 10th byte with value 44 and the 1337th byte with CC, send me this. And as an example, I will then apply these patches and run the binary to make sure it works. If it works properly, I will pay you for your efforts. Deal. Please give me the patch. Okay, that sounds interesting. We've tried running the program. We can use it, but we of course want to bypass this copy protection. So let's open this in Binary Ninja. And let's look at the main function. So this is the main function of the program. So basically you can see that there's like a main path here that goes all the way to the end, and then there's like a bunch of things for it, like for it to abort. So you can see here, for example, failed to read key, empty message, key must be exactly this many characters, failed to read message to encrypt, empty message, sorry, your license only allows. And then we can see here that it actually does the actual encryption. It's like crypto secret box is a function here, and there's like bytes to hex conversions and stuff. Okay, so that's interesting. So what does this program do? It calls this like call hash text segment. So text segment is the name of the like actual code in your program. So this is somehow calculating some kind of hash over the whole thing, and then it calls validate integrity. So that seems like things we don't want it to do. I mean, because we're going to start modifying this program. So, but let's leave it at that for now, and then just check. So here we did have this function called validate license. So it calls this function, and then it either continues or it says invalid license exiting. So what happens if we just patch this? Just convert to NOP. So we patch away this call to this, and then in this branch here, we change it to, instead of actually making a decision here, where it says always branch. So we made these 2 changes to the binary. So now we'll not call the license validation function, and it will just skip. So we can save this as the Zeta Cryptor PRO patched, and we can try to run this. And now it says program has been tampered with exiting. So that's not good. It detected our modification. So we need to change more things to the program. So maybe we should just patch this whole thing away then. So just like convert this to NOP and convert this to NOP and tell it to always take this branch. And then we save it again and then we run. Nice. So now it asks us to give a key and a message. And it says that it's an empty message, even though we did provide a message. So there is something funky going on with the program. It's broken somewhere. So let's look further down here. And we can see here at this place, what is this actually doing here? It's taking this something runtime hash and then this data here, and it's taking a value from both of these and comparing against each other. So maybe it's using this hash. So what's in this data thing here? It seems to be some kind of values, and then runtime hash are all just zeros. And where is this done? It's used, if we look at references to runtime hash, you can see it's referenced inside the hash text segment and the validate integrity. So maybe this thing actually takes like a hash of the whole thing, and apart from the validate integrity function, it will actually check this hash a couple of times in the code. So here it says it does this comparison, if they're not equal, it will run this thing where it will just like zero out the register, and that seems odd. And here we again have this pattern. So this is some other data. What data is this? Oh, it's just the next data after the runtime hash. Maybe we can change the type of this to because I guess that all of these are these checks. So maybe we can change this to like a char 32 maybe. Oh, it's actually even longer. It's 64 characters. Yes. So now we can see if this is. Oh, cool. So here we have, in this place here, it references the runtime hash, and here it references it at offset 8, and here at offset 10, and offset 18, 20, 28. So we have the same pattern in all of these things. You see, it's like it's doing a comparison against the hash, and then if it's not correct, it will like run one instruction, like this instruction, this instruction, this instruction, this one, this one, this one, this one. Yeah. So let's just patch all of those away. Like disregard. So here we say that we will always take this jump no matter the result of the comparison. We just do this for all of these locations. Cool, and then we save that, save the contents only. And then we try to run this again, and then please input the message to encrypt. Sorry, your license only allowed. Oh, right. We also need to bypass the check. So it's not crashing anymore, but since we never actually read the license, that thing also doesn't work. So this is this part here. So we patch this away as well and just always take that branch. And we run again. Key, message, encrypted. And let's make sure that it works for like a long message. Oh. Key, message. And that works. Okay, so it looks like we have defeated the copy protection of this program. So we have this now, the original version and the patched version. And now we need to provide this, like the diff of these to the remote server. So let's just write a small program that will calculate the differences between these two programs. So we read the whole original program, and then we read the patched program, and then we have the thing that should keep oh, by the way, we make sure that we double check that they are both the same length, and then we do this. So we have the offset, the byte 1 and byte 2 in this enumerate original data and the patched data. So basically what we're doing now is that if the 2 bytes differ, then we add the offset and the new value to this list. And then for each patch element in this list, we put this together into the format that was requested. First the offset as 2 bytes, and then the actual the value. So the patch offset, the patch value, and we add this to the patch. We need to import the struct thing. Okay, let's run this. Let me just check that the formatting is correct. Oh, maybe we have to do this actually. Right. Okay, sorry, just some Python errors. Okay, cool. So now it's printing a patch. So let's just connect to the server and provide this patch to the guy. And it works. Okay, cool. I will apply this patch and try the program. A few test cases. Nice, it worked. I said I was going to pay you. Unfortunately, I spent my last money on rare first edition comic books, but here is Flag instead. I hope that is okay. I guess that's fine. So that's how you solve this one. Yeah, that was a bit quicker than the OS one. So, and that's a very nice place to end this stream for today, I think. So, do we have any questions or comments from the people who have been watching this? Please write them in the chat. So we've gone through most of the web and all of the reversing challenges, and we have the pwnables, the crypto challenges, the forensics challenges, and the boot to roots category left. So I will try to schedule another stream for, I think, Wednesday probably, and yeah, that will be the continuation of this. So yeah, I will create an event here on my channel, so you can see it if you're subscribed, and it will be posted in the Discord as well. And there was questions about what's going to happen with pony racing. So for those who don't know, pony racing is a show that we've been running for the past year, where people do like a live head-to-head exploitation challenge race, and it has been put on hold for the time being, but it will be back later. But we don't have any specific updates on that right now. And yeah, so with that, I will close the stream. So thanks for watching. I hope you learned stuff and that you will compete in other CTFs. Oh yeah, by the way, I have 2 good resources to link to. First of all, there's the CTF Time website, ctftime.org. It's a website, a calendar, ratings, and so on for CTF. So here you can find upcoming CTF competitions. So really good calendar. They also have like a I think they have like a Google Calendar feed, so you can like add it to your own calendar to keep track of the competitions. Another thing is that on my GitHub gist, I have a list of tools that I keep. It's like fairly updated, like curated list of tools that I use for CTF related activities. So those are great things to check out. And as I said before, picoctf.com, a good beginner CTF that they keep it runs every year, but they keep their challenges up so you can play previous year challenges. Also, currently you have the Ångström CTF running right now. They do a similar thing. You can it's like kind of beginner-ish oriented. It's like, I would say the difficulty is like somewhere between like beginner and regular. I mean, yeah, so similar to Pico, and it's running right now actually, but they will keep the challenge up. But you can still join the CTF and play, and it runs until like late Wednesday. Yeah, so basically until midnight on Wednesday, or like at 1 a.m. on Thursday. So yeah, go play that. And if you have any general questions or queries about CTF or so, just don't hesitate to reach out to me. So yeah, that's it for today. Good night.